These are the notes for lesson 83 for Algebra 2. It's due April 21st. That's on a Tuesday. Before I start on those notes though, there's a few I want to show you from lesson 81. So you're going to write these down first, lesson 81. A lot of you missed this one on the practice for 81, so I want to show you how it should work. A lot of you did this, ln 2x minus ln e. You didn't finish. Remember, these two are being multiplied. You have to get rid of this. You can't leave any multiplication or any division in an argument. So it has to further expand into that. Now, ln e is 1. Some of you just canceled the ln e and didn't put the 1. You have to put the 1. So make sure that when it's ln e that you do put a 1. Now, if it's ln e and you've got a 3 up here, then yeah, you can cancel it and just put the 3. But when it's just ln e, you have to put the 1. And you have to break this up. Your arguments, these numbers after the natural log, when you're writing it as a sum or a difference, cannot have any multiplication or division at all, okay? Then another one I wanted to show you that some of you missed is this one. And I just want to go over it again too. So there's a couple of different ways. The way I showed you to handle this 3 is to put it in front. Like this. So then you have that, okay? So then when I take this apart, the 3 has to be distributed. So I have to have 3ln, put equals 3ln 5 plus, because that's a multiplication right there, I've got to split it apart, 3ln e squared, okay? Minus 3, because the 3 has to be distributed to everything, ln v cubed, okay? So 3ln 5, nothing can happen to it. 3ln 5, that's an ln, not an h. Okay. Plus, now here the ln e cancels, and you can just do 2 times 3 and get 6. Minus, here, this 3 needs to be multiplied by that 3. Just like that 2 was multiplied by that 3, this 3 needs to be multiplied by this 3 and get 9, and then you've got ln v. So that's the way that one should have worked. So just be careful with those. I wanted to show you those things. Okay, so now for lesson 83. On lesson 83, you're actually going to write some quadratic equations from roots. If you can FOIL, you got this one. So it's quadratic equations from roots. So we're going to be going backwards. Instead of us taking a quadratic equation and factoring and finding the roots, we're going to be given the roots and have to take it to a quadratic equation. So let's see. Our roots are -3 and 5. Those are our roots, -3 and 5. So if those are our roots, that means in parentheses, they were actually x plus 3, x minus 5, because they changed signs. Then you just do FOIL, x squared minus 5x plus 3x minus 15. Not going to go slow through FOIL. Y'all should know how to FOIL. X squared minus 2x minus 15 equals 0 because they ask for an equation. That's the biggest problem on here, is you forgetting the equals. You've got to put equals because they ask for equations. So if they ask for equations, you've got to put equals 0, or you can put equals y, but you've got to make sure you write an equation. And the only way you can write an equation is with an equal sign. Okay, so that's those roots. Let's see, my roots now are -4 and 7. So I put them in parentheses first, which means I change the signs. Do not forget to change the signs. Then I FOIL, x squared minus 7x plus 4x minus 28. So that gives me x squared minus 3x minus 28 equals 0, because I'm asked for an equation. Okay? Then let's see. This time I want 3 equations from the roots 5 and 2. I want 3 equations from the roots 5 and 2. So again, x minus 5x minus 2, because I changed the signs. X squared minus 2x minus 5x plus 10. So that's x squared minus 7x plus 10. So here's one equation. Another equation, change the signs. So that's a second one. A second equation, 2, that's not 10 squared. Second equation, multiply the original one by 2. So 2x squared minus 14x plus 20. That's all you do. That's a third equation. So that's 3 equations. They all have the root 5, 2. Why? Because I found the original one, and then I just changed something about it to get 2 others. So that's 3 equations. Actually, now they're equations because I put the equal zeros on them. That's 3 equations that have the root 5, 2. Okay, so now my roots are, oh, I don't know, -4, -1. Those are my roots, -4, -1. I want 3 equations again. So it'd be x plus 4, x plus 1, because I've got to change both of those signs. So x squared plus x plus 4x plus 4. X squared plus 5x plus 4 equals 0 is one equation. Negative x squared minus 5x minus 4 equals 0 is a second equation. 2x squared plus 10x plus 8 is a third equation. Okay, then sometimes we only have one root. So here my root 6. Looks like roof, and now it just looks terrible. That's a T. Wow. Okay, so when you have one roof, I just said roof. Oh my gosh. Well, at least y'all will laugh. One root, the root is 6. So there's a couple of different ways you could do this. You could see this as x minus 6 all squared. It's got a multiplicity of 2. Or you can write out x minus 6, x minus 6. Because you have to have a quadratic. So you're going to have an x squared somehow. Okay? So if you're given one root, change the sign, it's squared. Or you can write it out twice and FOIL it. You could use the shortcut x squared minus 6x minus 6x plus 36. So x squared minus 12x plus 36 equals 0. So now my root is -2. So if my root is -2, that would be x plus 2 all squared, which would give me x squared plus 4x plus 4 equals 0. Or -x squared minus 4x minus 4 equals 0. Or 2x squared plus 8x plus 8 equals 0. There are 3 different equations. There you go. If you want 3 different equations. Okay, now for a little more challenging stuff. When you have complex roots. Now we've seen those. We've seen where we get an I. When you have complex roots, what happens here, and if you're just given one complex root, you have the conjugate. So if you're just given 3 plus 2i, you have the conjugate of 3 minus 2i. If you're given 3 minus 2i, you have the conjugate 3 plus 2i. Okay? So what happens here is you go ahead, you put it in parentheses. So notice how I changed the sign on the 3, but I don't change those 2 signs, because if I change the plus to a minus, there's the minus. If I change a minus to a plus, there's the plus. So really don't have to change those signs. You do have to make sure you change the sign in front, though. If you don't change that sign, it's going to mess up. Now there's a shortcut, because if we were to do, it's not really FOIL because they're not binomials, but it's like that. If we were just to do distributive property on this, it would take forever, and y'all wouldn't do it. I wouldn't even do it. That's why I figured out this shortcut. Okay, so what you're going to do is this. You're going to square the variable. You're going to square the real part with the plus sign. The real part is always going to be squared with a plus sign because these signs will always be the same. And it's like you're multiplying -3 times -3, so it's a positive. Then you're going to square your imaginary part with the subtraction sign, and you're going to make sure you square your entire imaginary part, like the 2i. The 2 has to be squared, the I has to be squared. And it's always a negative. Why? Because it's a positive times a negative. A positive times a negative is always a negative. Then you're going to find the product of the real part and the variable. And you need 2 of them. Okay? That is part of the shortcut when you square a binomial, like I did over here. -6, -6. It's the product of the 2. You need 2 of them. Okay? So it comes from that shortcut. Okay? Now you need to fix this. That's the shortcut right there. You square the variable, you square the real one with a plus, you square the imaginary one with a subtraction, you find the product of the 2, and you need 2 of them. So x squared plus 9 minus 4i squared minus 6x. Then you fix this because you should remember I squared is -1. So -1 times -4 is a +4. 9 and +4 is 13, so x squared minus 6x plus 13 equals 0. Make sure you put equals 0, otherwise it's not an equation. So that's how you work with imaginary roots. Now I want to do at least 2 more of those just to show that shortcut again. Okay, so let's see. 6 minus 4i and 6 plus 4i. 6 minus 4i, 6 plus 4i. So again, I want you to put it in parentheses. Change the sign, so we change the sign on the 6. Then square the variable, square the real part with an addition, square the imaginary part, the whole imaginary part, the 4 and the I with a subtraction. Find the product of the real part and the variable, which is -6x, and you need 2 of them. X squared plus 36 minus 16i squared minus 12x. Again, I squared is negative. That'd make a positive 16. 36 and 16 is 52, unless I can't add, which, you know, sometimes there's an issue. So it should be x squared minus 12x plus 52 equals 0 because it's an equation. Guys, I'm going to be looking for that equals 0, and every one of these you do. And if you don't put equals 0, it's going to be wrong because it asks for an equation, so it's got to have an equals 0. Okay, I want to do another one of those. Let's see. I want to... Let's have -1 plus 4i and -1 minus 4i. -1 plus 4i, -1 minus 4i. Because you haven't seen with that being a negative how you change that sign. So x plus I plus 4i, x plus I minus 4i. And again, don't change these signs, because if we do, if I change that to a minus, I've already got a minus there. If I change this to a plus, I've already got the plus there. So I'm just kind of being lazy. X squared plus 1 squared minus 4i all squared plus 1x plus 1x. That's the shortcut. Square the variable, square the real, square the imaginary with a subtraction. Find the product of the two. Here that is a plus 1. So those are both plus 1x's. X squared plus 1 minus 16i squared plus 2x. I squared again is -1. That makes it a positive 16. 1 plus 16 is 17. X squared plus 2x plus 17 equals 0. Okay? Again, equals 0. And I wanted to show you that negative, but watch this number. If this number is positive, put a subtraction in there. If this number is negative, put a addition in there. So be careful with that, okay? But that shows that shortcut. Then you'll see where you've got something like 3i and -3i. I would just FOIL this. Actually, you could do a shortcut, guys. These are conjugates. This is like this is going to become the difference of 2 squares. It's going to become the difference of 2 squares right here. Then x squared minus 9i squared. Then because the I squared is -1, it's going to look like x squared plus 9. But there is a shortcut to it because they're conjugates. So you can just square the x, and you can square the variable, square the imaginary part, and go from there. And it equals 0. If I wanted another one, -x squared minus 9 equals 0. If I wanted another one, 2x squared plus 18 equals 0. Please read your instructions carefully. If you're asked for 3 of them, make sure you put 3 of them. Watch your signs. Let's see, let's do another one like that. 9i and -9i. So x minus 9i, x plus 9i. So again, conjugate, so x squared minus 9i all squared. So that's x squared minus 81i squared. I squared is a -1, so x squared plus 81 equals 0. Okay, then I was going to do example 4, but we're not going to. That's enough. So let me go ahead and make the assignment now. You're going to do the warm-up on page 586. You're going to do the practice. Now, if you look at my MCS, the practice says that you do A through G. I don't want you to do A through G. I just want you to do A through F. So make sure you skip G. Okay? Then let's see. You're going to do numbers 1, 2, 4, 7, 9. Now, on my MCS, it said to do 12. I want you to skip number 12. I don't want you to do number 12. I changed my mind on that. 14 is just FOIL. When you look at 14, you're doing Z times I. It's just FOIL. So 14 is just FOIL. 16, 19, 21, 22, 24, 25, 26, and 27. Number 14, again, is FOIL. And then there's a few others I want to talk about, like number 16. Number 16. Let's see, on number 16, you have D equals a square root of L squared plus W squared plus H squared. It gives the length of the diagonal D of length times width times height, rectangular prism. Prism A has a width of 3, a length of 7, and a diagonal of 9.1. Prism B has width of 2 inches, length of 8 inches, and a diagonal of 10.2. Which prism has the greater height by how much? So you have to find H on both of them. So on A, prism A has width of 3. You're looking for the height. So width of 3, length of 7, and then your diagonal is 9.1. So you're going to square this to get rid of the radical first, and then you should be able to go from there. The last move you're going to make is square rooting because you want H, you want the height. Then on B, you're going to put 10.2 in for the, nope, yes, 10.2 in for the diagonal. Then for B, it's got a width of 2. You're looking for the height again. And then a length of 8. So that's how those set up. Square both sides. That gets rid of the radical. You need to do 8 squared, 2 squared, combine it. You'll subtract that number. And then you're going to take the square root for your height. And then you decide, you know, what the difference is between the height on number 16. So that sets 16 up. Then let's see, number 21. Okay, on 21, the reason I want to show you 21 is because I want to remind you about how I want you to find an angle measurement using law of cosines, not the way the book does it. I don't want you to do the way the book does it because I've done some shortcuts for you and it makes it easier. So we want angle C. So here's C. So remember, when I showed you law of cosines, I said, okay, if you want to find angle C, you're going to take the two sides around it, 10 squared plus 4 squared. You're going to subtract the side opposite it, and you're going to divide by 2 times 4 times 10. Okay? Now be very careful when you put this on your calculator. You have to put an extra set of parentheses around the numerator. So let me show you how to put it in, just to make sure, you know, you don't want to miss it by putting it in your calculator wrong. So it's inverse cosine, then a set of parentheses, 10 squared plus 4 squared minus 2 times 10 times 4. Hold on. I didn't put the rest of the numerator in. Dummy. Okay, so it's 10 squared plus 4 squared minus 7.5 squared, because 7.5 is the side across from the angle you're looking for. Then I close parentheses, divided by 2, divided by parentheses 2, times 4. Okay, so first, before I go any further, because this will go off the screen, so you do inverse cosine, that's second cosine, another set of parentheses, you put all your numerator in, 10 squared plus 4 squared minus 7.5 squared, close parentheses, divided by parentheses, 2 times 4 times 10, close parentheses twice, and then hit enter. I didn't mean to do that. Okay, anyway, so that's how you get number 21. That's how I want to see it. And then write down the angle measure, which I actually showed on there, so you should be good on that one. So that was number 21. Number 22 shouldn't be a big deal. 24, on 24, this is where you use the 1/2 AB sine C. It's that special formula. You're given the two sides around an angle, and so you use this formula for finding the angle measures on 20, to find the area. Sorry, you're finding the area on 24. And you're given two sides and the angle between. So you're given side A and side C, and you're given angle B. So this still works. You put your two sides and your angle here. Then 25, let me get you to a certain point on 25. Let's see, so you've got A equals PE to the RT, where P is your principal, E is just E, R is your interest rate as a decimal, and T is time. And they tell you all that. To the nearest 100%, what annual interest rate, so you want R, would be necessary for the value of an investment to double in 10 years. So you want the amount to double. So that means we can start with 1. It doesn't tell us what to start with, but it does tell us we want 1. There's R, and this is 10. You should be able to go from there. You're just finding R. Make sure you put it as a percentage when you're done. So make sure whatever decimal you get, change it to a percentage. But that sets it up. That's finding R just like you find K. Just like you find K. 26 and 27, easy, just plugging into piecewise functions, which y'all are doing very well on that. On 30, it's writing the equation. You better make sure you put equals 0. Again, this is due 4/21. Remember, you've got test 16 and review 16 due Friday, due this Friday the 17th, and then this isn't due until Tuesday the 21st.